So we've seen that we can think of the probability of an event as its relative frequency in the long run. Let's examine this idea a bit more. So let's look at a specific example. So we'll use an example that we've looked at before, that of a die roll. So remember, a die has faces numbered 1 to 6. So the sample space is the set consisting of numbers 1, 2, 3, 4, 5, and 6. So these are the outcomes. So imagine that we roll this die 10 times and we list the results of our 10 trials. If we roll a die 10 times, we might get these results. Okay, so now we can calculate frequencies and relative frequencies, and sometimes it's useful to use a table to do this. So we'll make a table, and in our rows we'll have outcomes in one row, possible outcomes, and frequencies in another row, and relative frequencies in the third row. So the outcomes are 1, 2, 3, 4, 5, and 6. And now to work out the frequencies, we just go through each of these outcomes and we count how many times it happened. So 1 happened 3 times, so its frequency is 3. 2 just happened once, so it has frequency 1. 3 just happened once as well, so that has frequency 1. 4 has frequency 1. We got 2 5s, so that has frequency 2. And 6 happened twice, so that has frequency 2. So those are the frequencies of the various outcomes. And now the relative frequencies, well, we just take each frequency and we divide by the number of trials. So that's dividing by 10, so we get 0.3, 0.1, 0.1, 0.1, 0.2, and 0.2. Okay, so those are the frequencies and relative frequencies of the various outcomes when we carried out these 10 trials. Now what I want to do is I want to add up some of these numbers. So let's add up all the frequencies. So I'm going to create a separate column called totals. So I'm not going to total up the outcomes. I don't care about the total of the outcomes here. But what I do care about here now are the total of the frequencies. Well, without even adding them up, we should be able to say what the total of the frequencies is. Because if we add up all the frequencies, then that should give us the total number of trials. And it does, right? 3 plus 1 plus 1 plus 1 plus 2 plus 2 is 10. And that makes sense because every trial results in one outcome. So when we add up the total frequencies for each outcome, we should get the total number of trials. That's 10. And now to get from the second row to the third row, we just divided by 10. So when we add up the total relative frequencies, we should get 1. And we do. Right? 0.3 plus 0.1 plus 0.1 plus 0.1 plus 0.2 plus 0.2 is 1. So this is a very important concept. When we add up the relative frequencies of all the outcomes, we get 1. So let's write that down. Okay, so the sum of the relative frequencies of all the outcomes is 1. That's an important thing to note about relative frequencies. And remember that probability is relative frequency in the long run. So this is going to work for probabilities as well. And this is a really important point about probabilities of outcomes. So the sum of the probabilities of all the outcomes is 1. So that's a very important fact to remember about probability theory. That when you have an experiment and you list all the probabilities of all of the outcomes, that they should all add up to 1. Okay, let's use this concept to solve a problem. So suppose that John and Kathy are playing a game of chess, and suppose that we know that Kathy is a better chess player and that she's twice as likely to win as John. And the question is, what is the probability that Kathy wins? So the shorthand here, P brackets Kathy wins, that stands for the probability of the event that Kathy wins. So we want to find out that probability. So how can we do this? Well, in this game, there are only two outcomes. So the sample space is John or Kathy, depending on who wins. So the possible outcomes are that John wins or Kathy wins. And we know that the probability that John wins plus the probability that Kathy wins must be 1, because the sum of the probabilities of all the outcomes is 1. Okay. And we know that the probability that Kathy wins is twice the probability that John wins, because we're told that she's twice as likely to win as John. So now we have two equations here and two unknowns, the probability that John wins and the probability that Kathy wins, and we just have to solve. Let's use the first equation to eliminate the probability that John wins from the second equation. So we can rearrange the first equation by bringing the probability that Kathy wins to the right-hand side. And now we can substitute in 1 minus the probability of Kathy wins for the probability that John wins in the second equation. And now we just have one equation with one unknown in it, so we should be able to solve. So first of all, let's multiply in the 2 on the right hand side here. So we get 2 times 1 minus 2 times the probability that Kathy wins. And now let's bring this term here to the left hand side. And what we're left with on the right is 2 times 1, which is 2. And here on the left hand side we have the probability of Kathy wins plus 2 times the probability of Kathy wins. So that's 3 times the thing that we're looking for. And now finally divide by 3 to get our answer. So the probability that Kathy wins the game is 2/3.